Today we're working on a 2011 Buick Lucerne for the evaporative emissions. And this line in the back right there is our tank vent, and that other line is our fuel line with our fuel pump. The sensor right here is our fuel tank pressure sensor. Looking at this diagram from AllData, we have our canister right there with our line running to the fuel tank. That would be our fuel pump module. Here's a blown up view of our canister with the lines running to the fuel tank.
Looking at our wiring diagram here, on the right here we have our EVAP vent solenoid. This is our normally open solenoid. This is going to receive key on power and then be ground side controlled through the PCM. Same with our EVAP purge solenoid. This is also going to have key on power with ground side control from the PCM. And then we also have our fuel tank pressure sensor. This is just going to have key on power as well and a common ground. And then we have our sensor back to the PCM.
Looking at our scan tool, there's a variety of PIDs for EVAP. Our fuel tank pressure sensor is reading 2.2 volts, which translates to negative 6.38 millimeters of mercury. As we scroll through, we can see some of these tests have already ran. We have a fuel level sensor. Engine speed is IAT, ECT, mass airflow, APP. These are all sensors that are included in the EVAP system. Moving along to our engine bay, this is our EVAP line right here. And it goes into this solenoid right here. We have now unplugged this solenoid and are going to see what it does to the PIDs. When the solenoid was unplugged, we got a P0443 evaporative emission purge solenoid control circuit. Our EVAP purge solenoid command percentage, as you can see, with increased throttle, the percentage increases and then it goes to 0% on decel. We have now probed the purge solenoid valve with the picoscope. This is the pattern that we're seeing. Here's a view of the pattern. This is a single section of it. So we have 12 volts, and then it's ground side actuated. Goes down to 0 volts, and then it spikes up to 77 volts, and then comes back down to 12 volts.
It sounds like a cool system, but it sounds like
And our solenoid on time
and then like if you get a leak, it also
is
falls onto it.
8.9 milliseconds. As our engine RPM increases, our waveform gets slightly tighter. Then it returns to normal when RPM decreases. Here we have our smoke machine turned on the air, hooked up to where our EVAP line goes into our engine, and our reading right now is extremely high. This line would be a 20 thou leak, and that is a 40 thou leak, so we are much above that. And that is because our vent line is naturally open. We are now filling this EVAP system with smoke in order to find our leak. As you can see, our EVAP system is completely full of smoke, and when we take our gas cap off, it is now coming out through the fill hole. We now have our smoke coming from the top of the tank where our vent hose is. Now we have this smoke machine running through the gas cap adapter, and it's filling up our entire EVAP system and coming out of this line up here.